Today we will be talking about solving systems of equations by graphing. So, there are multiple steps to this. The first step is you want to make sure that both your equations are in slope-intercept form. Now this isn't necessary, but seeing that it is the easiest to graph lines when they are in slope-intercept form, if they are not in slope-intercept form, you generally want to get them there. Alright, step 2 would then be to graph both lines, and then step 3 is your answer is where they intersect. So, whenever you do this, in general, this is your normal circumstance where you have two lines with two different slopes. If you have two lines with two different slopes, most of your answers, if these were your x and your y, most of your answers are going to look something like that, where you've got two lines and they're intersecting at one point. So if you've got two different slopes, you're only going to have one answer. Alright, now there are two special circumstances. If you have the exact same line, so when you solve for both equations you realize, hey, those are the exact same line, those are going to look like that, where it's the exact same line just on top of each other. So whenever you see this, that is going to be infinite solutions. And of course, our last scenario, I'm going to try and squeeze it in here, would be you have parallel lines. And if you have parallel lines, that's going to look something like, let's say that and that. So if you've got two parallel lines, then you have no solution. So parallel lines are the ones that most people get tripped up on, is if you have two lines that are never going to intersect, that means you have no solution. So once again, there are three different types. Most commonly, you're going to see when they have different slopes, and you're just going to have one answer for those. Alright, if you have two lines of the exact same line, then you're going to have infinite solutions. And if you have parallel lines that are not the same line, then it is no solution. For A, we have y equals 1/3 x minus 4, and y equals negative x plus 4. So once again, step 1 is get both equations to slope-intercept form. Well, the bright side is, this is in slope-intercept form, and this is in slope-intercept form. So step 1's already done. So step 2 is just to graph both lines. So for the first line, y equals 1/3 x minus 4, our y-intercept is negative 4, and our slope is 1/3, which means I'm going to go up 1 and right 3. So my first line looks like that. And for my second line, I've got y equals negative x plus 4, so my y-intercept is at positive 4, and my slope is negative 1. So I'm going to go down 1, right 1. So this auto fills in the line for me, and I can see that they are meeting right here. And that point would be 6, negative 2. So my answer for A would be 6, negative 2. For B, we have y equals x minus 6 and y equals negative x plus 2. So once again, you want to make sure that both are in slope-intercept form, which in this case they already are for us. And so the next step is to graph both lines. So once again, our first line, y equals x minus 6, our y-intercept is at negative 6, and our slope is 1, so I'm going to go up 1, right 1. And for our second line, y equals negative x plus 2, our y-intercept is at positive 2, and our slope is negative 1. So I'm going to go down 1, right 1. And so from looking at the graph, I can see that it is meeting at 4, negative 2. So the answer for B would be 4, negative 2. For C, we have y equals 3x plus 2, and y equals 3x minus 4. So once again, we want to make sure both are in slope-intercept form, which they already are, and now we want to graph both lines. So the first line, y equals 3x plus 2, our y-intercept is 2, and our slope is 3. So I'd want to go up 3, right 1. For the second line, we have y equals 3x minus 4, so our y-intercept is negative 4, and our slope is 3, so I'd want to go up 3, right 1. So if I look at these two lines, I can see that they are parallel lines, which means they are never going to intersect, which means these two lines have no solution. So C's answer is no solution. Now, there was one tip-off that I could have had as kind of a shortcut. If you ever see y equals 3x plus 2 and y equals 3x minus 4, we'd notice right away that they have the exact same slope. And remember, if the slopes are the same, then we know that those two lines are parallel. And if we knew that those lines are parallel from the equations, then we could say right away that there are no solutions. So if you graph them, that's great. If you catch an eye onto it and you're like, oh, that's a nice shortcut. I already noticed that they have the same slope and different y-intercepts, so there can't be any solutions, so it would be no solution. For D, we have x plus 2y equals negative 8, and x minus 4y equals 4. So our first step, getting them both into slope-intercept form, we have to do, because neither of those lines are in slope-intercept form. So taking care of the top one first, I got x plus 2y equals negative 8. So I'd want to subtract x from both sides. So I got 2y equals negative x minus 8. And then divide both sides by 2. So I have y equals negative 1 over 2. I can't simplify, so negative 1/2 x. And then negative 8 divided by 2 would be negative 4. So there's my first line. And for my second line, x minus 4y equals 4, I'm going to subtract x from both sides. So I end up with negative 4y equals negative x plus 4. And then divide both sides by a negative 4 to get the y by itself. So y equals negative 1 over negative 4 would be positive 1/4 x. And then 4 divided by negative 4 would be negative 1. So my two lines are right here. And so now if I graph those, so my first line was y equals negative 1/2 x minus 4, which means my y-intercept is at negative 4. And my slope is negative 1/2, so I'm going to go down 1, right 2. And my second line, y equals 1/4 x minus 1, my y-intercept is negative 1. And my slope is 1/4, which means I want to go up 1, right 4. Okay, so looking at here, I can see that my two lines are intersecting right at that point, which is negative 4, negative 2. So my answer for D would be negative 4, negative 2. For E, we have x minus y equals 2, and negative 4x plus 5y equals negative 5. So once again, we want to make sure both are in slope-intercept form, which in this case neither of them are. So just like on the last one, we have to get each of those equations to slope-intercept form. So our top one, x minus y equals 2. I'd have to subtract x from both sides. So I end up with negative y equals negative x plus 2. And then divide both sides by a negative 1 to get rid of that negative. So I got y equals negative over a negative, which would be a positive x. And then 2 divided by negative 1, which would be negative 2. Alright, and for my second equation, negative 4x plus 5y equals negative 5. So I'm going to add 4x to both sides. So I get 5y equals 4x minus 5, and then divide both sides by 5. So y equals 4/5. I can't simplify, so I'm going to leave it like that. 4/5 x, negative 5 divided by 5, which would be negative 1. So my two equations are right here, and now it's time to graph. For my first equation, y equals x minus 2, my y-intercept is negative 2, and my slope is 1. So I'm going to go up 1, right 1. So my first line looks like that. For my second line, y equals 4/5 x minus 1, my y-intercept is negative 1, and my slope is 4/5, so I'm going to go up 4, 1, 2, 3, 4, and right 5, 1, 2, 3, 4, 5. So my two lines are intersecting right there, which is at 5, 3. So my answer for E would be 5, 3. For F, we have 3x plus y equals negative 2, and 6x plus 2y equals negative 4. So once again, our first step, check if both lines are in slope-intercept form. In this case, neither of them are. So we've got to get both of them to slope-intercept form. So for my top line, I have 3x plus y equals negative 2. Subtract 3x from both sides. So get y equals negative 3x minus 2. And from my bottom line, I have 6x plus 2y equals negative 4. And I'm going to subtract 6x from both sides. So I have 2y equals negative 6x minus 4. And then divide both sides by 2. So I have y equals negative 3x minus 2. So right now I can tell you that the answer is going to be infinite solutions because I got the exact same line here as I did down there. So I could tell you even without graphing that there's going to be infinite solutions. Because once again, if you get the exact same line, even though they have the same slope because they are lying directly on top of each other, that's going to be infinite solutions. So if I show you that on the graph, so our line is y equals negative 3x minus 2, so our y-intercept is negative 2, and our slope is negative 3, so I'm going to go down 3, right 1. And if I were to graph the other line, if I were to graph the line on this program, it's going to do something weird, but I'm going to graph it there and there, and it puts the two lines not on top of each other. But if you were actually graphing it, they would be on top of each other. So that means you have infinite solutions. So once again, our answer for F, because the lines are exactly the same, would be infinite solutions.